So today we're going to talk about reconstitution, all right? And reconstitution is something that you've been doing your whole life. Nothing new. You've been doing this. Reconstitution means to restore something to a liquid form. So reconstitution is all the time. One example is when I have students who don't like to drink water. They have a packet of Kool-Aid or whatever and a bottle of water, and they take the Kool-Aid and they pour it in there and they shake it up and they make that new product. That is reconstitution. In healthcare, we reconstitute medications because sometimes medications have a short shelf life. They become ineffective quickly. So we mix them at the bedside so that we can give it right away, and the patient benefits from this medication at its highest potency, right? So we mix them. When you reconstitute, you have a powder and a liquid, and together they make that mixture. The powder is a solute, the liquid is the solvent, and you make a new solution. The powder or the solute is usually milligrams. The solvent is in mLs, right? Think of mLs, L for liquid. And when you're done, you get a new concentration, a milligram per ml of the new solution. So, this is a normal dosage calculation question, right? You're ordered Zosyn 100 milligrams IV every 8 hours. Pharmacy sends you Zosyn 500 milligrams in 100 mLs normal saline. How many mLs will you get? First of all, disclaimer, I make things up. I make up the dose, I make up everything because I'm trying to prove a point to you. So nobody's ever gonna make Zosyn and have it there. No, I'm making all of this up. So this question, pharmacy has done the work. It's already mixed. It's 500 milligrams in 100 mLs. It's done. It's like going to the furniture store and purchasing furniture that is assembled, it's beautiful, it's done, right? Now, in contrast, when you go to a reconstitution question, you have the same question, but pharmacy says, we're not mixing it. You got to do it. So pharmacy sends you directions, right? They send you Zosyn 500 milligram. It's in a vial, and there's a label that says you need to mix this with 100 mLs normal saline to yield, to mix, to end up with, to create a 5 milligram per ml solution. So what I highlighted in red is what is the difference between a normal question and a reconstitution question. The key for reconstitution is knowing what to ignore. So I'm gonna move this information up, and I will absolutely let you take pictures in a little bit. So there are different types of reconstitution questions. You're always given the milligrams and you're always given the powder. You're always given the milligrams and the ml, these ingredients that you're gonna work with. So if you're given the milligrams and the ml, and then the yield, that final concentration is given, milligrams per ml, you have the golden best example of a reconstitution question. Sometimes you're given the milligrams per ml, but you only get the milligrams, or you only get the mLs. And sometimes they just tell you what they mix and that's it. Okay? We need the milligrams per ml. The milligrams per ml of the final product is golden. It's our best example. The final product is so important. Any information you were given about it, you must use. So this is the final product. Every information we get about it, we must use. So when they gave us the milligrams and the ml, and they told us the milligrams per ml, we're gonna use this to solve our problem. When they gave us milligrams per ml, but they only told us the milligrams, we're like, where are we gonna get the mLs? We go to the ingredients. When we got milligrams per ml and we only were told the final mLs of the product, the final product, we have to go to the ingredients to get the milligrams. And if we're just given the milligrams per ml, well, we gotta use that. So, when we go up here to our question, in the normal question, we were just given the milligrams on ml. There was no reconstitution to do. So we would solve that question using 100 mLs over 500 milligrams times 100 milligrams over one dose, and we would get 20 mLs per dose. In the reconstitution question, like IKEA, we had to put it together. So we have the milligrams, we have the mLs, and we have the yield of milligrams per ml. So we must ignore this milligram and this mLs because we have everything we need right here. We have the milligrams per ml. So in this question, we will only use that. 1 ml, 5 milligrams over the order, times the order, 100 milligrams over one dose is 20 mLs per dose. Okay? So I purposely created a fake question with the same information to show you why dosage calculation questions are not going to be a challenge for you because you've been doing this your whole life. All right? So I'm going to leave this up here. And I am going to put a question on the board. Hold on, and this will be, it is an image, and it's not the best, I apologize for that, but I think it could work. Okay, can you zoom in for me? All right, so look at question number 1. We have the order, 200 milligrams IV every 4 hours. Then the reconstitution part. It is available in a 2-gram vial, which must be reconstituted with 1 gram, each 1 gram with 2 ml sterile water. How much will you draw from the vial after reconstitution? So we always use the order. Absolutely. I don't want you to solve anything. I just want you to watch me. We always use the order. What will we use from that reconstitution? What will we use? Will we use the 2 grams, the 1 gram, 2 ml? What are we going to use? 2 ml, 1 gram. We have to use that. Yes. Now look at number 2. We have the order, then we have the drug is available 1 gram to be diluted with 5.7 mLs of sterile water. Each gram equals 6 ml. What will we use? You will use 1 gram 6 ml. You will ignore that. The 1 gram 6 ml is the concentration of the final product. Number 3. We have the order, then we have, it is available as polyethylene N, 1 gram, and it said add 3.5 ml diluent to yield 250 milligrams per ml. What will we use? 250 milligrams per ml. Okay? What about number 4? We have the order, it is available as oxycillin 1 gram, add 5.7 ml to yield 250 milligrams per 1.5 ml. What will you use? 1.5 ml and 250 milligrams. And then you work the question the regular way. The key is knowing what to ignore. Okay? All right. Thank you, man.